Hi, welcome back. I think we're in week 6 now. Very exciting. We're past the midway point, so we've only got a couple more weeks left of continuing to homeschool or learn at a distance, which is very exciting. So I want to first of all go over some of the things that we talked about last week in terms of speed, velocity, and acceleration. So the vocabulary that you need to review to make sure that you're really comfortable going into what we're going to study this week are force and motion. You need to understand that we measure force in newtons. You need to understand the 3 Newton's laws of motion. The first one, the law of inertia, and particularly the third law, which is for every action, there's an equal and opposite reaction. You need to understand energy, mass, and then also velocity and speed, okay? So please go back to last week's materials and review those. Once again, with all of what we're doing with physics, we want to constantly come back to that unifying principle that we have, which is that physical forces affect the movement of all matter on Earth and throughout the universe, okay? Big idea being energy is transferred when a force moves an object. And remember, we have several different kinds of force, some of which we talked about at the very beginning, and I told you that we would be coming back to those. And it is this week that we're going to be talking a little bit more about those. For today, the key concept that we want to be working on is that work is the use of force to move an object. So we want to be talking about some of the nuances in terms of what we talk about with force and energy and motion. We have energy, and we have 3 ways that we transfer energy, and that's conduction, convection, and radiation. But we also need energy to do work. So energy, work, force, power, they're all interlinking concepts, but they are not the same concept, okay? So with regards to work being the use of force to move an object, force is necessary to do work, all right? So to do work on an object, a force must be applied to an object, and the object must move in the direction of the force. So I have this object, which is a pen. I'm going to apply force to that object, and I'm going to push the pen. So force was necessary to do work on this object. I needed to use force in order to move the object, and the object was applied in the direction that the force moved the object, okay? If I was pulling it, I would be doing this direction. So work was being done to the right as opposed to work being done to the left. So we need to, once again, concentrate on this issue of direction, which is why we must, again, think about velocity. Velocity work is a scalar quantity in the sense that an object has to have some type of a direction, all right? So work is done only by the component of the force that acts in the same direction as the movement of the object. We can calculate work by multiplying the force applied to the objects by the distance that the object travels. So we're going to once again look at my pen. Let's say that I applied 1 Newton, because remember we measure force in newtons. I've applied 1 Newton, and I moved my pen 6 inches to the left. So we find out about the work that was done by measuring force, so 1 Newton by 6 inches. So the work that was done, which we measure in joules, was 6 joules. I had 6 joules of work done, okay? I applied 1 Newton of force. I moved my pen 6 inches. I multiply my 1 Newton by 6 inches, and we get joules for measuring work. So I have basically done 6 joules worth of work, all right? So objects that are moving can do work. Moving objects can do work. The gravitational force of Earth does work on water and other natural materials. So gravitational force of loose rocks can create landslides. Gravitational force on water can create waterfalls. So we have to remember that the force is not necessarily a physical force that we are applying with our bodies. It might be gravity, it might be electromagnetism. We always still measure force in newtons, and we always still measure work in joules. Also, that people use moving objects to help them do work. So we can also help ourselves do work by using objects. So if I wanted to move a huge stack of books, I might put the books in boxes and then put the boxes on a dolly, apply a bit of leverage, and I can then pull the dolly to do the work. So I can reduce the amount of actual effort that needs to be done to do work. So that's important to learn. I do want to talk quickly about a couple of misconceptions that we have. So solving a math problem in your head is not technically doing work. You're thinking, but you're not technically doing work. Writing the answer is work. So you need to remember it this way, is that when you're thinking through a problem in your head, you are not applying force and you're not moving an object. If you are writing your answer on a piece of paper, you are applying force to an object that is moving in the direction that you're writing. So you are working there. You are not working when you're thinking. Believe it or not, moving thought is not something we can measure in terms of force. So if you want to do work, you have to use force to actually move something. So there are a couple of misconceptions that I want to go back and take a look at. One of those misconceptions, I'm sorry, I lost the page, I was looking at something else, is that you might think that work continues even after a force ceases to be applied. In fact, an object can continue to move after force is removed. So think about kicking the ball, kicking a soccer ball. You're going to kick the ball, the force is being applied with the kick. The ball is continuing to move. However, there's no longer any work done because you're no longer applying force. Okay, it's a completely different concept. So that ball continues to move. It has momentum. It has energy, but it's no longer working because there's no longer a force being applied. So work only occurs when force is being applied to an object and that object is in motion or is moving. Another misconception is that you might think that force and energy are the same thing, or that energy is a type of force. Actually, force and energy are two different phenomena that are related through the concept of work. That means that the transferring of energy from one object to another is using a force, and that's something that we learned last year. So it's really important when we're talking about these concepts, and when we are sitting down and writing out these vocabulary words, we need to really think about what they mean. Understand that these are related concepts, but they are not the same concept, okay? So that's really, really critical that we learn that. And as we talk later this week about power, I want you to understand that the word power has many meanings in everyday language. Don't confuse the common meaning of the word for the physical meaning. That is that power is the rate of work or energy transfer. Okay? Sorry about that. My volume came on the TV, so we got a little bit of background noise there. The other thing as well is I'm using this book right now that I'm supporting a lot of material, an old book I used to teach from, which is the McDougall-Littell Physical Science book. I have actually found a link to this book online, and it has audio recordings of chapters that I'm actually using. So when we do a review on Thursday, I'm going to include the audio link for this entire chapter, because right now we're doing section 1. Tuesday we're going to do section 2, Wednesday section 3. The chapter has only 3 sections. We are going to have a test on Friday, so I'm probably going to attach the audio recordings for the last chapter we use and for this chapter for you to listen to the material to make sure that you fully understand the concepts as part of your review. And then we have another quiz or Quizlet / Testlet. I guess Testlet is probably the more proper, I guess, way of looking at that. So I'm going to start including some more materials like that so that you can listen to the chapter. I can't read through the whole chapter, but they have audio files of the whole chapter that will help you. All right. I hope we have a great day. I have been grading like crazy. Anything that was sent to me as of Saturday will be in the grade book before I go to bed tonight. It's Sunday. I'm taping your lesson on Sunday. So anything that you did not complete from March now has a 0 in the grade book, okay? That material is so old. If you go back and do the work, I will change the grade. I will give you a late credit grade, because really the goal here is that you do the work, that you learn the material. So please, but if you really, but it's going to affect your grade now. You need to go back into Schoolmaster and take a close look at those grades and fix those assignments that you've missed, because even if you're going to get a 50% for being a month late on the assignment, a 50% is better for your grade than a 0. So please go back and do that. It's going to be a hot week, so stay cool, but still try to go out early in the morning, get a bit of sunshine. It's all good for you. All right, bye.